Hello everyone, I am Atharva Teskar and today I will be demonstrating the use of Gaussian Naive Bayes Algorithm for classification on this dataset known as the biomechanical features of the orthopedic patients. The source of this dataset is the UCI Machine Learning repository. So let's start. Although you can use any one of the softwares that like Anaconda Navigator and Jupyter Notebooks for writing the software, but I'll be using the Kaggle kernels since it comes preloaded with all the libraries we require and the dataset will be available on the website too. So all you have to do is go to your Kaggle account, log in, go into dataset and search for this dataset called the biomechanical features. After which, this is the description of the dataset. The data contain there are two types of data called the column 3c vector.csv and column 2c vector.csv. We'll be working with the column 3c vector.csv, in which we have to classify the patients on three classes. Patients with spondylolisthesis. After which, let's go to the description of the data. The data consists of 6 attributes: pelvic incidence, pelvic tilt, lordosis angle, sacral scope, pelvic radius, and grade of spondylolisthesis. Right? So we will not download the data since we are performing it here in the kernel itself. Right? To give you a view of how the data looks, I have already downloaded. This is how the data looks. Classification. This is how your kernel in Kaggle will look like. So this is our cell. It's mostly in the form of a Jupyter notebook. So you can do everything here. You see that data is accessible here in our workspace. We are working with column 3c vector.csv. We'll copy the location of the data for our future use. Right. So before beginning with a machine learning project, all we have to do is import all the necessary libraries that we'll be requiring. Like we'll be requiring the NumPy for linear algebra, we'll be requiring pandas which provides us greater flexibility for managing our data. Then we'll import Seaborn, visualizing our data. Then we'll import the most important library, that's scikit-learn, and few of the things that we require from scikit-learn, that are scikit-learn, for pre-processing our data. Then we'll also require the algorithm that we'll be using here for classification. That's Gaussian Naive Bayes. Then we'll import this thing called train, test, split, to split our data into training set and the test set, so that we don't continuously keep training our data on the same set and then evaluate it on the same set, which may give us wrong results. Since the data has already been fit to the training set, it will give great results on rerunning the same data, but then it won't give good results on new data. That's why we'll split the data, we'll train it on one part and then we'll test it on the other. So after that, we all know that this is for linear algebra and data handling. This is again for data handling. This is for visualizations. This is our standard for algorithm. This is for pre-processing. This is Gaussian NB and all that. Now since we have imported all the required libraries, we'll go about preparing the data. We'll take the data, we'll store it in a variable now named data, and since this is a CSV file, we'll import the CSV file here. What we have to do is we'll drop all the rows which have some value missing in them so that we don't run into problems later. Then we'll split the data into two types, that's the main training data and the labels. Here we can see that the first 6 columns provide us with that features for training the data, and the last column is the label. So we'll separate it here using the iloc method. That's first 6 columns and the last one's a label. So here we have taken the last column as the label. Now what we do is we encode the categorical variables. Here again in the data set we can see that the label is in the class of the patients. It's in terms of words like the hernia, or normal. We all know that computers are better at crunching numbers than text. So what we'll do is we'll take each of this class and map it to a particular number. Right? Like we'll put hernia as 0, this as 1, so that all of these cases belong to the same numbers and we can represent them in the form of numbers so that it's easier for the computer to. We'll create a name called encoder. And we create a method so that we can easily access the encoder later on. We'll apply it to the class column of the data. That's the last one. Since we have that's the only column that contains categorical variables in our data set. And we'll fit our encoder to the last column. Right, so that's how we are done with encoding our categorical variables. Now we'll go about plotting the data. So we'll be using Seaborn for that. With this command we'll be plotting a heat map for our data. This is how we get the correlation between the various features, and we'll put the annotations. Right, so we're done with plotting the data as well. Now we'll go about splitting the data into training and test sets. Have S train. We'll split the data into these 4 variables. Right. We'll apply the train test split method function here, and we set the test size to 20% of the data set. We set the random state to 25 so that every time we run this program, or anyone who runs this program, will get the same results each time. So that's how we are done with splitting the data also. Now we do the main job, that is we'll create a model for prediction. I'll give it a savvy name called the predictor. And okay, assign it to the so that we can access it easily later on. Now we'll fit the data set to the model, and so we go about taking our predictor and fitting it to our model. So we are done with fitting the predictor to our model too. Now we go about printing the results, because we should be able to see how has our model turned out to be. So that's how we will now print the accuracy of the model and all that. We'll fit our model. Then we will get the accuracy of our model by using the score method from predictor. It will predict the values for a given input, and then it will compare whether the output which is predicted by the model and the real label do they match, and that's how it will give us a score on the accuracy of the model. So we'll take this and we'll see we'll get a true or false table after the comparison here, so that we can easily visualize whether the comparison was, the prediction was true or it was false. Did the prediction match with the correct label, or didn't it match? Now we go about final. And then we will take the transpose of this data frame. Because it will come out as a horizontal data frame rather than a vertical one. Take that transpose. columns from final. Right, just for our convenience. This is the final one, and we'll now actually merge these data frames so that we get a good view of what originally our data was, what our predictions were, what the labels were, and if our predictions matched with the labels. So we've created two data frames, and what we'll do is we'll just merge the final data frame with the final one data frame. We'll merge the X test data frame with the final data frame using the merge method from pandas. So here we go about creating a left index. We'll keep the left index. We'll also keep the right index. Right. So this is how we are almost done with our model. Now we'll just print. What the accuracy of this model is. What percent is the accuracy, and then we'll just put some nice stars here. So we are done with our printing our model, right? Just in case you are using this in Anaconda or any other software and you want to create a CSV file of your results, you can add this line to your code at the end so that the results will be stored in a CSV file. All you need to do is you need to set the encoding to UTF-8. You have to keep the index as false to prevent it from being saved there. Just in case, since I don't need it here, I don't need to save the results, what I'll do is I'll remove this line. I just get the accuracy of the model. Multiply the score by 100 so that we get it in percentage. Now let's run our model and see how does it work. Using Naive Bayes, this is the heat map that we had plotted. Right. So that's how we use Naive Bayes for classification. And thank you for watching. Please subscribe to my channel.